Okay, number 2 from the Chapter 7 homework. We kind of jump right in here with Chapter 2 to probably the most difficult problem that we're going to have in the chapter. There are several ones like this. I guess I should say the most difficult type of problem, the most steps involved. So I'll give you that heads up going to number 2, that if you're just starting out, the whole chapter isn't like this. There's a lot of simple problems in here. But really, we're just applying all the fundamentals of finance that we've learned so far. We're really calculating present values throughout this chapter. Is mostly what we're doing of a series of unequal cash flows. What becomes vitally important here is the timing, similar to like it was with bonds. We have to be real careful about which present value we're calculating, which we'll see in this problem. Something else I want to warn you about up front is I'm making these videos. I have misplaced my little thumb drive that allows me to put the calculator on the screen here for us. So I won't be able to show you the actual keystrokes for these problems, but I want to go ahead and make these videos anyway to get them up so you can at least hear me talking through the problem. And as soon as I either find that little on-screen calculator or I order a replacement, I'll go back and make these videos again with the keystrokes so we'll be able to see it. But give you that warning up front so we don't get all the way through the problem and then you find out I'm not going to show the calculator. If you have any questions about how to put this stuff into the calculator, it's nothing different than we've already done. You can go back and watch other videos about how to use the cash flow menu and things like that if you're not getting the right answers. But feel free to give me a call or send me an email and I can kind of walk you through the keystrokes for each problem. Okay, so for number 2, this problem says a firm expects to increase its annual dividend by 20% per year for the next 2 years and by 15% per year for the following 2 years. After that, the company plans to pay a constant annual dividend of $3 a share. The last dividend paid was $1 a share. What is the current value of this stock if the required rate of return is 12%? Okay, so there's a lot going on with this problem, and when there's a lot going on, I always like to start with the timeline and kind of map everything out and see what's happening. And as you can see with this timeline, there's a lot to figure out here. What I want to do is map out our cash flows. Chapter 4 is asking us to use a bunch of different variants of what we call the dividend discount model. In other words, we're going to find the price of a stock by simply finding the present value of the expected dividends. Okay, it's one way of valuing stock, assuming it pays dividends at all. And this whole chapter uses that concept in various forms. So we're going to map out what's going on here. Time zeros today, like usual, we want to find the value of the stock, or the present value of all the dividends we expect to receive out of this stock. And we've got to use the information in the problem to find these cash flows, or these dividends. So we started out, the last dividend it paid was $1 a share. And at the very beginning of the problem here, it tells us that they're going to increase its annual dividend by 20% per year for the next 2 years. Okay, so they started at $1. That'd be here at time 0, but we're not too concerned with that because it would have already been received. At the end of year 1, what we've got to do is take that $1 and grow it by 20%. So we're going to do it each step here is just grow it by the appropriate rate, take the previous dividend and grow it. Okay, so here we're taking the $1 times 1 plus 0.2. So this is 1 plus our growth rate here. And we do 1 times 1.2. It grows that $1 by 20%. And we find the actual dividend received at the end of year 1 is $1.20. Okay, so that took the previous dividend of $1, just grew it by 20%, and we find that we expect the next dividend to be $1.20. So that's the cash flow we're going to receive at the end of year 1. Okay, and we're going to take that and find the present value, put it into today's dollars. Okay, but we're going to go ahead and map out the timeline first before we start finding present values because we can lump a lot of this together. Okay, at the end of year 2, for the next 2 years, we're growing by 20%. So we're going to take this dividend we got at the end of year 1, and then we're going to grow it by 20%. It's going to grow by an additional 20%. So that's what's going on right here under the 2 tick mark. We take the $1.20 times 1 plus our growth rate of 0.2. So 1.2 times 1.2 is 1.44. So the dividend we expect to receive at the end of year 2 is $1.44. Right? After that, after the next 2 years, things change on us. The problem says that it's going to increase its annual dividend by 20% per year for the next 2 years and by 15% per year for the following 2 years. So after it grows by 20% for 2 years, now it's going to grow by 15%. So we're going to play the same game to find the dividends. It's just we're changing our growth rate is the only difference. So now we're going to take this dividend from the previous year, the end of year 2 of 1.44. That's what you see right here, times 1 plus our new growth rate of 15%. Okay, so that's 1.44 times 1.15. Okay, if you plug that into your calculator, you'll get 1.656. Hey, I'm going to go ahead and just write out the full number of decimals that I can see there to save myself from any rounding errors. And when I calculate this in the calculator, I'm actually storing the values. But you'll be okay if you just write it down to 4 decimal place and use those numbers. It's not going to cause you too many problems. Okay, so at the end of year 3, the dividend we expect to receive is $1.656. Okay, and that took just year 2's dividend and grew it by 15%. Okay, we've got one more year of 15% growth, so we're going to take this dividend at the end of year 3 of 1.656 and then multiply it at times 1 plus 0.15 here at the end of year 4 to find what the dividend is expected to be at the end of year 4. So when we do that multiplication, we find the dividend we expect to receive is 1.9044 at the end of year 4. Okay. Now after those first 4 years, what we call the supernormal growth period, if you've read the text, and I highly encourage you to do so. This stuff probably won't make any sense if you don't get some of the background from the text. Okay. After our 4 years of supernormal growth, starting in year 5, they go to a $3 dividend, and then it's just $3 forever. The problem says that after that, the company plans to pay a constant annual dividend of $3 a share. Okay, so it's just going to be $3. It's not growing anymore. They're just going to pay $3 every year. As long as we can foresee in the future. So as far as we're concerned, to infinity. Okay, so we'll get $3 at the end of year 5, $3 at the end of year 6, and ... so on. It keeps going. Well, here in year 5, we know what we call that. It's just a level, constant payment that occurs every year. That's a perpetuity from previous chapters, and we know how to find the present value of that. The problem we're going to run into is the timing. When we use our formula to calculate the present value of perpetuity, it gives us the present value 1 period back, so we'll still have to discount it. Okay, but we'll take that in step 2. In step 1 here, what I want to find is the present value of these first 4 cash flows, our supernormal growth period. That's what we're going to do up front. And since we've got 4 payments that occur each year, so at set intervals, but they're uneven payments, I'm going to use the cash flow meaning to get at that. You could also just find the present value of each one of those individually if you're more comfortable doing it that way. But I'm going to use the cash flow menu to try and save myself some time and some keystrokes. Okay, so what we're going to do is open up the cash flow menu here. You're going to hit second CF on the calculator. And then when you open up that cash flow, make sure you hit second clear work as well to clear out whatever was in there before. Because whatever problem you're working before, even if it was from the last exam, is still going to be in there. So you've got to clear that stuff out. Okay, and here's what you're going to enter for each one of these. Cash flow CF sub 0 is going to be 0. Right? We're assuming there's no cash outlay. Here, we're going to make it give us a present value. CO1 is going to be our first dividend of 1.2. That's what we got right here at the end of year 1. That's our first cash flow. We're going to get that once, so FO1 is going to be 1. Okay, and you hit the down arrow key to get each one of these. CO2, our second cash flow, is going to be 1.44. That's what we get at the end of year 2 right here. And so you'll punch that in and hit enter. We're going to get that once, so F02, your frequency, is going to be 1. Your third cash flow is going to be what we receive at the end of year 3, and that's the 1.656 that we found right here. Okay, and FO3, we're going to get that once, so have that entered as 1. And then finally, our fourth cash flow, the CO4 is 1.9044, and that's what we found right here at the end of year 4, 1.9044. Okay, and we're going to get that once. Okay, and once you've got all those entered, you're going to hit NPV, the NPV key, and the calculator is going to say I equals and ask you for an interest rate. Our required rate of return is 12% here in the problem. That's just like before. That's what we're going to use as our discount rate for all of these, our required rate of return. Okay, so you're going to plug in 12 and hit enter. Then you hit the down arrow key. It'll pull up the NPV, and you can hit compute. And what you'll find is the present value of those cash flows is 4.6084, about $4.61. Okay. Either write this number down or store it in the calculator somewhere, because you'll go back. We're going to add these up later. That's the present value of just simply these first 4 payments right here. So we're not quite done yet. That's not the value of the stock. That's just the value of the next 4 dividends we expect to receive. We still have the present value of the perpetuity to deal with. Okay. So in step 2, what we're going to find now is we've already got the present value of these 4 cash flows. Now we're going to find the present value of the perpetuity. Starting in year 5, the dividend goes to $3, and we're just going to receive $3 per year forever. Okay. Well, we know the formula for finding the present value of the perpetuity. The book changes it around a little bit, but it's the exact same formula, where it calls it, in the book, this is P0 equals D1 over capital R. Now, why they switched to using capital R for required rate of return when we're talking about stocks, There's some reason in the literature that they do that, but it's really confusing. We've been using a little r the entire time, so that's what I'm going to continue to use on the formula sheets. And so our little r is our required rate of return. And what I've done for each one of these formulas is written the subscripts in terms of the problem that we're looking at here. We're going to find the price or the present value at the end of year 4. So that's P sub 4. Okay, and that's to remind us so we don't forget when we calculate this thing that when we use this formula, we're taking this dividend in time period 5, the dividend 1 period ahead, okay, and we plug that in and divide it by the discount rate. What we find is the present value 1 period before. So in this problem, we plug in the dividend at the end of year 5. What we find is the present value at the end of year 4. Okay? And we can't just add that up to the present value that we had before because all those other ones have been brought back to time period 0. We still have to do that with this perpetuity. Okay? But let's plug in these numbers first. When we use the present value of perpetuity formula here that we've rearranged to make sense for our formula, or renamed, okay, we take the $3 dividend that we're going to receive at the end of year 5, divided by our required rate of return of 0.12, and we find $25 as the present value of the perpetuity. So you can see what I filled in here in the timeline is the present value of that perpetuity right here is $25. Okay, that's at the end of year 4. Now we have to take that $25 and discount it back to time period 0 so that we can add all these up. We're comparing apples to apples. Okay, so we take that $25 and we're going to discount it back to today, to time period 0. And you can either use your calculator to do that, just make 25 the future value, and 4 in and 12 your interest rate, and do it that way. Or I find it a little bit quicker just to use the formula at this point since we're familiar with it rather than punching all that into the calculator. But whichever way you're more comfortable with, you'll come up with the same answer. So you take the 25 divided by 1 plus 0.12 raised to the 4, and you'll find that's 15.888. That's now the present value at time period 0 of those dividends that we expect to receive. Okay. Now that we have, this is in terms of time period 0, okay, our 15.888, it's the present value of our perpetuity. And then we also have the present value of the first 4 dividends we expect to receive at time period 0, 4.6084. That's all in time period 0, so we can just add those numbers right up, and we'll get the value of the stock. Okay, so we just add up the 4.6084, that's the present value of the first 4 dividends, and then plus the 15.888, that's the present value of that perpetuity that it turns into at the end of year 5. And so we add those guys up and we find a total present value of $20.50. Okay, so that means that is the present value of all the dividends we expect to receive over the life of the stock. So if that's the way that we value stock, using this dividend discount model, that $20.50 is what we would be willing to pay in order to receive those expected future dividends. So that's what would be the price of the stock.